Alright, nice. And it's not frozen, right? Oh no, you're gone. You're definitely gone. Okay, you're back. But it says that I have 0 viewers in my stream manager. But you didn't leave. Wow, Twitch is being very buggy. And OBS. Are you a ghost in the machine? A ghost in the shell? So 2 hours per day, 20 days. First quiz is due then. Yeah. I don't think I really need this. Oh. Oh, there, it says that I have a viewer now. Complex numbers. Okay, so forced response to sinusoidal. That's number 3. I guess I should have another thing here for it. Oh, I want to do a little bit of quiet music. Oops, that's pretty loud. Okay.
Value we did last semester. Let's use some voltage source, some Let's take this circuit. We have a simple circuit which has a resistor
probably a
and an
DC
inductor.
circuit then.
That's it. With a voltage source. And instead of using a DC value we did last semester, let's use some voltage source, some V maximum, some number in the front with cosine WT.
F. WTF.
That could be like 5 cosine 200t. Now the way we dealt with circuit like this with a DC source last semester wasn't really...
Wait, W is, there's like a, there's a fancy thing for W's. Is that magnetic flux or power? No, it's power. What's it? Just watts? I thought that there was a different word. Something.
That bad. We created a first order differential equation. I gave you a handout. If there's the equation, there's the answer. Here a little bit more challenging. If I do KVL here, Kirchhoff voltage law says sum of the voltage in a closed loop is 0. So negative.
Okay. Kirchhoff's voltage law. I know I've studied that. Yeah. Gains and drops are equal. Conservation of charge. The conservation of energy. There's a junction and a loop rule. Kirchhoff.
More challenging. If I do KVL here, Kirchhoff voltage law says sum of the voltage in a closed loop is 0. So negative Vm cosine Wt plus, this is I here, the voltage here will be R times I. The voltage here will be what? L di dt is equal to 0. Which means if I rewrite that L di dt,
How's the audio levels? Is it all okay?
plus R sub I equals Vm, some number in the front, cosine Wt.
F.
So that should, notice there's only one unknown, which is I, and that should allow me to solve for I.
Oh wait, I is not. Well, I is current.
Well, T is time, W is a constant. When you plug in, for
Nice.
example,
Thanks.
in this outlet, if I plug in a hair dryer or a toaster, W for us in the US, well, what's the frequency in the US?
12
How many
hertz?
hertz?
Oh no.
60 hertz.
Mm-hmm.
In Europe is 50 hertz. W is actually 2 pi f. So if you multiply, so it's a constant, 2 pi times 60, which is 120 pi, which is usually 377. So a lot of the problems in our book, when you look at them, W will have a value of 377. So the cosine 377 t. The reason? Because it's a frequency of 60 hertz. If you're in Europe, the frequency is 50. This becomes 2 pi times 50, which is 100 pi, and that's 314 t. Well, different frequency, and they also use different amplitude. Here, like our outlet, 120 volts. In Europe, they use 210 to 20. Now, in the lab, when you go to the lab, you can make W any number you want to because we get these signal generators. You make the frequency any number I want it to be. I can make the frequency 10 hertz, I can make it 1,000 hertz, I can make it 500 hertz. So that W can change in the lab. You can use any number. And now the question, how do you solve this differential equation? Well, if your actually voltage is cosine, your current is also going to be a cosine. But what's going to happen, instead of just cosine WT, you might have a phase shift in it. So let's assume we know it's going to be that the current, and we'll see what that number is going to have some number in the front.
Oh, I'm going to share this stream to an electrical engineering group. Get more nerds in the chat. Oh yeah. I think it was maybe computer engineering. Which one was I in? Yeah. Oh my goodness, 4:30. Jeez, is that like your normal wake up or is there something going on? Oh gosh. But when you do the training, is it done socially distanced though? I think, except for the... except for the fact that it's super early in the morning, I don't think you need the luck. I think you'll do fine. Me, on the other hand, I don't know if you heard what these professors are putting me through this semester. One has not released the syllabus or any homework, and the other has also kind of gone this route of giving me like this one test and no practice quiz, no practice homework, so I don't know what kind of questions are going to be on the exam. I don't know if it's going to be like a circuit diagram that I have to analyze or if it's going to be some equations that I have to solve. And I have no clue how long I get to spend on the exam or how many questions it is. And the professors are kind of slow to write back. Yeah, I don't know what's up with that. As Jerry Seinfeld says, what is the deal? Well, thanks for coming in. It looks like I got someone else that's in here too. I don't know who they are. Oops. I don't think that it was the post in the computer engineering group, because that has to be approved by an admin. Where'd the little thing go? I don't think I've ever had an open-ended test before. Like, I've never been one to ask the professor, like, how many questions or are on the exam or how much time do we get on it, because somebody else has always asked that and the professor has always given an answer. Of course, I'm speaking about, like, professors I've had prior, and this is, like, a totally new situation. But I've never heard of tests being like this, where you just have no information about the tests. I think the professors are probably overwhelmed with some sort of personal COVID related situation. The classes were kind of like supposed to be, one of them was supposed to be on campus and is not. And yeah, I don't know. That music's a little loud for my taste. Okay.
And we'll call it some constant, I have no idea what that number is, some value, cosine WT, plus some number, sine WT.
Look at the way he's
now,
holding
where
two
did
pens.
this come from?
Who does that?
We found out that when you apply a cosine function, the voltage, the current will have a cosine function.
I'm gonna just go back to that. Check that out. I've been made fun of for the way that I hold a pencil like this. Actually, it's like, how do I do it? Oh, I hold it like this usually. Like, yeah, but he's doing too. I find his videos are really good here. I like this method because you can pause it and rewind. And the teachers don't yell at you if you ask questions. Like Mr. Peruti in Algebra 1.
So where did this come from? Well, we found out that when you apply a cosine function, the voltage, the current will have a cosine function, but will have a phase shift. So for example, I'll show you where this came from. Your current, I'm going to show you where this equation came from, might have some value like this, some constant in the front, will be the same W. The W doesn't change, but it's going to have a phase shift to it. It's not going to be in sync. The only time we'll be in phase if you have a purely resistive circuit. This is not a purely resistive, there's an inductor here. There's going to be a phase shift to it. So that angle is going to be shifted by some degree, let's call it beta, for example. Purely resistive circuit. This is not a purely resistive, there's an inductor there. So it's going to have a phase shift to it. So that angle is going to be...
Wait a second. Phase shift. I know what phase is. Phase shift. Why is he talking about that? Let's confirm the definition of a sinusoidal function. So, yeah, I know what a sine wave is. Ooh, a vibrating guitar string is a sinusoidal function. That's cool.
Be shifted by some degree, let's call it beta, for example. I erased my trig identity, cosine alpha plus beta. Anyone remember cosine alpha plus beta, what that identity for it? cosine, I think it's cosine minus sine. I'll find it. It's cosine alpha cosine beta minus sine alpha.
But wait,
sine
before you
beta.
go, did you learn anything? Oh, I don't know. Well, thank you for coming. I hope you learned something.
So if you plug in these here into this equation, this is alpha, and this is beta, then your answer is going to be, there's k in the front, it's going to be k times cosine Wt times cosine, whatever that phase shift, that's some number, minus sine Wt sine beta. Remember, this is cosine beta as a constant. When you multiply it by k, you have another constant. So you have some k1 cosine Wt sine beta is a constant. When you multiply it by k and by minus 1 is also another constant. Could be a negative number. So that's why we said the current's going to be something like this. K1, I1, whatever you want to call it, some constant cosine Wt plus another constant sine Wt. And now the question, what is L1 and L2? Or, what is I? I need to solve for I1, I2. I can't tell you what the current are. I know what these values are. So how would I find the answer to them? Well, there's my equation right here. We know this is the answer. So take the current here and plug it right there. You should be able to solve now for I sub 1, I sub 2. So L times, what's the derivative of this current? Let's go through the math. Remember your calculus. What's the derivative? I1 is a constant, cosine Wt. Derivative cosine is negative sine, right? That's negative I1 W sine Wt. Plus, what's the derivative sine? Cosine I2 W.
Dude, that's so cool. Totally let me know. Speed shifting the switch power on and off via a component. I want to know what component you're talking about. So yeah, whatever you're on, it sounds like you're on to something, and I definitely want to hear about it. So definitely send that through. Sounds dope.
U cosine Wt plus R times I. R is this one times I, which is what? I1 cosine Wt plus I2 sine Wt. All of that should equal Vm cosine Wt. Now I can break it down to two parts. I'll take one part with the cosine of Wt, and in it I should be able to put this piece, L times I2W, plus R times I sub 1. I'm collecting like terms. Can you see it? This times that, plus this times this. That's the cosine. Let's look at the sine. the sign, what do we have? R times I sub 2 minus this one, L times I sub 1 W. All of that equals Vm cosine Wt. For this side to equal that side, the coefficient of the cosine on this side must equal the coefficient of cosine on that side. And the coefficient of the sine on this side must equal the coefficient of the sine on that side. So the cosine on this side is what? L I2 W plus R I sub 1 is equal to Vm. And the coefficient of the sine on this side, R I sub 2 minus L I1 W, has to equal the coefficient of the sine on that side, which is a 0. There is no sign there. We have two equations by two unknowns. We can solve for I1 and I2. Now you can use substitution if you want to. This equation says R times I sub 2 equals L W times I sub 1. Divide by R, I sub 2 equals what? L W over R times I sub 1. Bring that equation down. LW times I sub 2. Instead of I sub 2, let me put what? LW over R, I sub 1, plus R times I sub 1 equals Vm. Multiply everything by R to clean it. LW squared, I sub 1, plus R squared, I sub 1 equals Vm. You can factor I squared.
Vm is power.
I mean I1, right? Not I squared.
Voltage.
LW or L squared, W squared plus what? R squared? What's I sub 1? It's Vm over L squared, W squared plus R squared. Now we know what I sub 1 is. If I know what I sub 1, can I find I sub 2? Absolutely. What is I sub 2? LW over R times I sub 1, which is Vm over L squared, W squared plus R squared. So we managed to solve for I1, I2. That means we know what the squared W. W squared plus R squared. So we managed to solve for I1, I2. That means we know what the current is. Now if we have numbers for these, if that was an example with numbers in it, I'm done. Here, this is a lot of work for a simple problem. It is. Imagine if you have a couple of loops and all that. It's going to be a nightmare. So is there a shortcut to solve these problems? And the answer is yes. When your source is a sine or a cosine, we're going to use a method called phasor, which is complex numbers. That's what we discuss, complex numbers. So basically what we're going to do, we're going to take a problem that's in time domain. That's this problem. Convert that to phasor, which is complex then solve it in phasor. Then convert it back to time domain. Well, if the math is not that bad, you know, like this wasn't really a bad math. If you know the answer is going to be like this. If we had numbers for this is actually a quick problem to solve in time domain if you plug in real numbers. You know, it won't be that bad. But with L's and all this, it makes it a little bit ugly. So you can do it. Sometimes we use the different, actually later in the course I want to use Laplace, which is a nicer way. Now this method phasor only works when your source is sine or cosine. It does not work if your source is, we did last semester, like a DC value, unit step function, a ramp function, something else. It doesn't work. So this method we're going to be looking at is the quickest way to solve a problem when your source is either a sine or a cosine. The Laplace? Yeah, well actually, but it's not quicker. It's not quicker than this. With sine, cosine, this is the quickest way. Yep. You'll see that when we get to it. You know, like solving a quadratic equation. There's multiple ways. You can solve using the quadratic formula. You know that method works regardless of what kind of a problem you have. Is it really the quickest way? No. Because if you have x squared minus 4 equals to 0, you got to be silly to go use a quadratic formula. There's a couple other techniques quicker than that. The same thing right here. Laplace down the road will solve almost any problem. Is it the best way? If you have a sine cosine, this way is the quickest way. You know? So why would I go in that direction? So I'll try to use this method if my source is sine cosine. In real life, most of the problems, we have sine cosine. So phasor is very popular for us.
Nice. Alright, I think I'm going to end the stream. I'm actually...
quick recap of capacitors.
Quick recap, it's 42 minutes,
we said
mister.
the current through a capacitor, I equals C.
So, yeah, I'm going to end the stream, but I'm going to upload these videos to my YouTube channel, which is Emma Serendipity live streams. Right here. I've got just 3 so far. I got 7, 4, 9. Okay.